Okay, let's continue the discussion about a basic computer program to convert a binary base 2 number into a decimal number. Just a quick review of what we're doing. We want to write the program, we want to input the binary number, so we'll type the number, let's say 101, and then we want to have the program convert that binary number in a decimal into a decimal number. So we do it as follows. First, we look at the units digit. We say, okay, we're going to take a 1. We're going to add to that 0 times 2, and then 1 times 2 squared, which is 4. So 1 plus 4, add the numbers, and we get 5. So this would be how we want the program to execute. Now, to this point, we have gotten, if you look down here at the bottom, our program begins with the input statement where we input the binary number. Now, we're inputting the binary number as an ASCII variable of zeros and ones. Then we compute the length of that ASCII variable. That's how many digits there will be in the binary number. Now we're going to set the variable that accumulates the decimal number. And we're going to do this by running through an I loop where we run through all the digits in the binary number, computing 2 to the I, and we'll be adding those to the decimal number. With that, there's a little statement in here that ends the program in case we don't input any number at all, which I'll skip over. Those are these 3 lines. Then we start for I equal 1 to n, and we increment a counter which works backwards. Why? Because as we input the ASCII character for the binary number, this is the first character, this is the second character, this would be the third character, which in this case n is equal to 3. So we want to start adding up their numbers, starting with the units number, then the 2's, and then the 2 squareds. So we want to actually add it up in reverse order that we input it. So we run through the I loop. I would be the first character we input, but an I equals 1, and I equal 2 would be the second character. I equal n is the last character. So I set I backward equal to n plus 1 minus I, so that when I is equal to 1, I backward is equal to n. So it starts with the nth character that we input, which would be the units digit, and then it goes to the 2's digit when I is equal to 2, because then n plus 1 minus 2 becomes n minus 1, and so on. So this is counting backwards through the number. We pull off the digit using the mid dollar function in BASIC, and then we check to see that ASCII character. Since our binary number is all going to be zeros and ones, the ASCII character will either be a 0 or a 1 ASCII character. So we check to see what the ASCII code is of that character S star. If that character is a 1, we're not going to want to add anything to our sum. If the character is a 1, we're going to want to add something to our sum. But if the character is a 0, we're not going to want to add anything. So we check. Okay. Now, the ASCII code for the character number 1 is 49. So we put in a statement that does the following. 130. Now here we've generated the ASCII code for the binary character, and we check to see if that's 49. So we put if ch equals 49, then we want to add a term to the sum. 140. We'll indent this a little bit. And we'll say, we'll take our number, the decimal form for the number, decimal, decimal, equals decimal plus 2 raised to the I minus 1 power. I minus 1 power. So when I is equal to 1, that'd be the units digit, and we have 2 to the 0 power. So we're just picking off the units digit and adding it to the value of decimal, which is initialized to be 0. Then when I is equal to 2, we're taking the 2's digit, and if that's equal to 1, if the 2's digit is equal to 1, then we add 2 to the value of decimal, and so on. So whenever the ASCII character is equal to 1, we add something to our sum. Okay, then we have statement 150. 150 will be else, E-L-S-E. Then we put 160. We end the if statement, end if. And then we go 170, next I. Now 180 is print the binary number comma a $, comma equals the decimal number close parentheses. Come on, print. The binary number equals the decimal number, comma, DECIMAL, and then 190 is end. Oh, that didn't work, did it? End. So let's list this. I'm going to run it, enter the binary number, 101. The binary number 101 equals the decimal number 5. Well, that's right. Let's just try another one. Run 101101. Now, I won't know if this answer is right or not. And we run into an undefined line. Haha, there's some type of an error there. List. (1011) equals the decimal number 11. I wonder why it's running now. Let me try run again. Run 10111. Run. I don't know. I must have typed something in incorrectly because it does appear to be running now. Run. Okay, it seems to be running right. So that's an example of list. Here's a program that inputs an ASCII character, which represents a binary number. It's only zeros and ones. Computes the length of that. Then it sums up the number in reverse order, beginning with the units, and then the 2's, and then the 4's, and then the 8's, and so on. So it runs backward through that ASCII character, checks to see if that ASCII character is a 1. If it's a 1, it then adds the appropriate power of 2 to the sum decimal, and continues until it accumulates the total value of the decimal number. Okay, so till next time.